Thursday the 8th of May, and today's topics are scatter graphs, inequality regions, and recipe questions. So, scatter graphs to start. Now, you need to be able to identify the types of correlation. So when it's going up from bottom left to top right, that is called positive correlation. The opposite direction is called negative. And when it looks like that one on the right, we would say it has no correlation. Those two variables aren't linked at all. And that's what a scatter graph does. It describes the relationship between two variables. So we have this question. The scatter graph shows the information about the height and the arm length of 8 students in year 11. Now, before you even read the question, get into the habit of drawing a line of best fit. Okay? So, your line of best fit should go through the majority of the points, and it does not have to connect to 0. Don't think about it too much, okay? Just do it quickly and don't overthink it. Don't count how many points at either side. That's going to get me 1 mark somewhere in a scatter graph question. So let's have a look about what it's asking us. It says, what type of correlation is it? Well, we've just talked about that. That is positive. It's not letting me write. How annoying. Go. And then it says a different student in year 11 has a height of 148 centimetres. So I'm going to find the axes which height is on and see where 148 will be. With this scale, every 1 square is 1, so that's nice and easy. So 148 would be here, and I'm going to draw a line up with my ruler, and then I'm going to draw a line across, and that gets me 83. So that will be 83 centimetres, and there'll always be a little range for these answers. Recipe questions. So the first type here is a non-calculator question. We've got a recipe for 30 biscuits, and it's saying, tell me how much I need of everything for 45. So what I always do is I kind of make myself a little table. So I've got 30 there, I want 45, and I think, non-calculator, what's the highest common factor between those two numbers? And that's going to be 15. And how am I getting from 30 to 15? I'm dividing by 2. And then I'm timesing by 3. So we'll divide each of these ingredients by 2. And then we will times them by 3. And that's our answer. 45, 345, 225 and 3. Now this next part, Jill has only 1 kilograms of self-raising flour. She has plenty of the other ingredients. What's the most amount of biscuits she can make? So for 30 biscuits, she needs 230 grams of flour. And she's got 1 kilogram. 1 kilogram is 1,000 grams. So I'm going to think about what have I got to times by to get from 1,000 to from 230 to 1,000. So if I do 1,000 divided by 230 on my calculator, I get quite a nasty decimal, but that's okay. I'm going to leave it on my screen. And I'm going to times the other side by the same thing. So times that by 30, and it gives me 130.43. Well, we just want the maximum number of whole biscuits that she can make. So that will be 130 biscuits. Next things, this is higher only, is inequality regions. And these questions can be quite tricky. But what we're going to start by doing is we're going to look at the equations that they've given us, or the inequalities that they've given us, and plot them as equations of lines. So y is less than or equal to 5, we're going to start by plotting y equals 5. That goes through the y-axis at 5, and you must label the lines that you plot. Next one, y equals 2x. So a quick way to plot this, there's no y-intercept. So it's going to start at 0, and that 2 means for every 1 square I go across, I'm going 2 up. So I'm going to go here, 1 across, 2 up, 1 across, 2 up, etc. Carry it on for the whole grid. Label it. And then next one, y equals x plus 1. So the y-intercept for this line is 1. And the gradient is 1. So for every 1 square I go across, I'm going 1 up. So I can draw that on here. And it's really important that you label them so you don't lose any marks. So now it looks kind of obvious that it's going to be that little region in the middle, but it's not necessarily. So they do this as a bit of a trick sometimes. So make sure that you check. And how we can do that is, if I look at the first line that I plotted, y equals 5, the inequality is y is less than or equal to 5. So that means it could have been anything underneath here. And you're going to draw these arrows on to show your examiner you understand that. The next one, y is less than or equal to 2x. Now I think that's really hard to see which side of the line it is. So what I would do is I'd pick a really nice coordinate one side of the line. So I'm going to pick this coordinate here, 4, 4. That's nice. If I substitute that in, 4 is less than or equal to 2 times 4. 4 is less than or equal to 8. That's correct. So what that means is everything, the side of my line, which is the same side as that point, could be within that inequality, could satisfy that inequality. So everything this side. And then finally, y is greater than x plus 1. So again, we'll pick a nice coordinate. I'm going to use that 4, 4 again. Why not? So 4 is greater than 4 plus 1. Well, 4 is not bigger than 5. So this time, I don't want the side of the line where that point was plotted. So I want everything this side of this line. So that leaves me with this little region here, which is what we expected it to be. The questions asked us to label it R. Mine's a bit small, so I can't do that. But in an exam, you would obviously be able to do that.